Alright, so I'm going to do part D and F of activity 8.4.7 in this video. So for each infinite series, we're supposed to see if it converges or diverges. So for part D, we have the infinite series of 100 to the k over k factorial. And I think the best route to go is to use the ratio test since we have this k factorial in the bottom. So essentially what we're going to do is see if this series behaves like a geometric series, which has a common ratio and we know always converges. So we're going to see if it behaves like a geometric series as k gets really, really big. So we're going to take the k plus first term and divide it over the kth term of the series, and we're going to take the limit as k approaches infinity. So when we do that, we get the limit as k approaches infinity of 100 to the k plus 1 over k plus 1 factorial times k factorial over 100k. So we know that most of it is going to cancel out. So for the 100k plus to the k plus 1 and over 100k, all we're left with is 100 in the numerator. And then for the factorials, everything cancels out except this last term here, which is the k plus 1. So we're going to get the limit as k approaches infinity of 100 over k plus 1. And as k gets really, really big, it's going to overtake this 100. And so we're just going to get 100 divided by a ginormous number, which is just going to approach 0. So this is our ratio. And like a geometric series, since our ratio is less than 1, we know that it converges. So now I'm going to do part F. So we have the infinite series of k to the third minus 1 over k to the fifth plus 1. So we know that for big K, k to the third minus 1 over k to the fifth plus 1 essentially just becomes 1 over k squared because these ones really don't matter. So now let's use the limit comparison test, and we're going to compare our k to the third minus 1 over k to the fifth plus 1 to 1 over k squared. So we're going to take the limit as k approaches infinity. And when we do that, we get the limit as k approaches infinity of k to the fifth, right, k squared times k to the third, minus k squared over k to the fifth plus 1. So even though this k squared is going to get really, really big as k approaches infinity, it's not going to matter in relation to these k to the fifths. They're going to just get so much bigger. So really all we're looking at is the limit as k approaches infinity of k to the fifth over k to the fifth, which is just 1. And 1 is a positive finite number, so we know that our series here in question is going to behave like the series of 1 over k squared. And we know that 1 over k squared, that series converges because of the p-test. Right, so 2 is greater than 1. So we know that our series converges. So I think that's it, and I'll do part I in the next video.